I'm using Jupyter Notebook for this assignment, and the working environment is Python 3. I have two of my code file, part 1 and part 2, in working directory of Jupyter Notebook, which is desktop. And first, for part 1, we run it. You can see that output files are all generated in working directory, which is desktop. Quickly walk through you from the top. Here is dividing the inaugural corpus into two data sets, pre-World War I and post-World War I, and then normalize it. And here is generate unigrams text file. The file looks like this, with associated probabilities of word in both datasets. And then do the same thing for bigrams, and the output is also with associated probabilities in both datasets. The third question is for the union set of most frequent 1,000 bigrams from both datasets with stop words and length less equal than 2 words filtered. Select bigrams with largest difference in probabilities before World War I and post World War I and pre World War I, and generate plot. The plot is also in desktop. Next is calculating PMI. I used the code professor gave us. This is for pre-World War I. And this for post-World War I, and extract economy in either position and write output. Output is like this. For extra credit, I did the same thing as above, only replacing the word economy with word war. And here's the result. Okay. And for part 2, here is 3 text, and I combine them as T. And add laplace smoothing to conditional frequency distribution. And then this is the code generating sentence using 3 methods. There are 2 assumptions for this part, because the samples call only returns possible following words that are originally in conditional frequency distribution instead of whole vocabulary. So I'm assuming it returns the whole vocabulary. The second assumption is that their probabilities of them add up to 1, or this part code won't work. So here are examples of the output which matches the sample output.